Welcome back to Distributed Generation and Smart Grid lecture series. In this video, we are going to discuss about smart meters. A smart meter is one of the most important device used in the smart grid. Smart meters is an advanced energy meter that obtains information from the end user's load devices and measures the energy consumption of the consumers and then provides added information to the utility company and or system operator for better monitoring and billing. So with a smart meter, electrical data such as the voltage and frequency are measured and real-time energy consumption information is recorded. Smart meter supports bidirectional communication. That is the important thing. That is a communication between meter and the central system. Also, smart meter has the built-in ability to disconnect or reconnect certain loads remotely and can be used to monitor and control the user's device also, so that they can manage the demand and loads within the smart building. And the smart meter typically record energy hourly or more frequently and report at least daily. And these smart meters enable two-way communication between the meter and the central system. So here the wireless communication options in common use include a cellular communication or Wi-Fi or wireless ad hoc networks, wireless mesh network, low power long range wireless network like LoRa, SIGME communication methods, etc. are used. Several smart sensors and control devices supported by dedicated communication infrastructure are utilized in a smart meter. So a smart meter's data is the combination of unique meter identifier, the data timestamp, and the various electricity consumption values, and all these are collected or these are collected by the smart sensors. So you can see two block diagrams which are conventional energy meters and a smart meter system, and you can see that a conventional energy meter, the different blocks are a residential or industrial customer, then conventional energy meter, manual collection of data, and the manual billing. But in a smart meter, from the residential or industrial customers, we are using a smart meter. So smart meter will collect all this data and communicate. There will be a communication interface protocol and a gateway. Then that is there are two-way communication. You can see the bidirectional diagram here, where they are communicating with both the customers and utility. And finally, the data are stored in a database through a communication interface protocol. This is a basic metering architecture of a conventional energy meter and a smart meter. From the utilities perspective, they can use the information collected from the smart meters to realize the real-time pricing by which companies can limit the maximum electricity consumption, and they can try to encourage the users to reduce their demand on the period of peak load. So the typical functions of a smart meter, they can be listed as First one is a two-way communication function, then data collection function, then a data recording function, then data storing function, then load control function. They can even switch off or switch on the load as a part of load demand side management. Then programming function, security function, display function, and finally the billing function. So these are the typical functions that is performed by a smart meter. And there are many benefits for using a smart meter for a utility and also a consumer or a society. So a typical uh, smart meter system benefits for utilities are: it actually saves a lot of money by improving the remote area reading and billing system, by avoiding the manual billing, so that you can save a lot of money. It gives utility the ability to better manage during peak load times. It makes more efficient use of energy and grid resources. It offers new tariff model in the electricity market, because you can introduce a real time or dynamic pricing, because this device is continuously monitoring the energy consumption, so that you can provide a dynamic pricing tariff to customers, so that they can shift their energy demand from a peak period to off peak period. It improves the transformer load management for the transmission line, etc. For the consumers cases, the benefits are: it shows the customer data about their electricity usage habit. So they will receive the information regarding how much energy they are using time by time, because it is a smart meter. They have the facility to communicate with both users and both consumers and utility. So it gives customer more accurate and timely electrical billing. It helps customers to better use the electrical equipment during the expensive hours. It facilitates customers to switch or delay their electrical equipment with a significant consumption to less expensive hours. So the meter itself switch off or switch on the particular equipment as a part of load side management, uh, in order to shift the load from a off peak period to off peak period. Then for a government, it stimulates the economy by investing the smart metering network. It improves the environmental condition by reducing the CO2 emission. Then it leads to reduction of consumption by increasing the awareness of consumption pattern. Also, it helps better load forecasting for power grid and prevent large scale blackout. It gives data for improving the efficiency and reliability of the supply. So these are some of the smart meter benefit for the different domains. Then let us discuss about once we are introducing a smart energy meter, you can introduce different types of tariffs also, because we are continuously monitoring the energy consumption. You can introduce a dynamic pricing. So what is a dynamic pricing? So dynamic pricing is one of the emerging areas of research in the retail electricity industry. So it is a demand side management technique that can reduce a peak load by charging different prices at different times according to the demand. So that is what is a dynamic pricing. So retail electricity market generally offers flat pricing or a block pricing. So prices remains unchanged irrespective of the demand in case of a flat pricing. And while in case of block pricing, the per unit rate of electricity either increase or decrease with the increase in the slabs of electricity consumption. So revenue management and dynamic pricings are economically and technically effective operational tool successfully implemented in various industries. So Uh, this dynamic pricings can be useful to customers in terms of their monetary savings. Suppliers can find it useful because reduction in the peak capacity investment, better planned operations, and cost reflecting prices. Because dynamic pricing is nothing but the consumers are well aware of about their energy consumption by time, so they can manage their load if their energy usage efficiently. They can even shift their energy usage from high price period to low price periods. Also, that will be in a way it will be helpful to utility because they can reduce their energy consumption or peak capacity from higher value to lower value. So dynamic pricing can help producers postpone investment decision by shifting the peak load from peak period to non-peak hours. So, and this kind of pricing, dynamic pricings have different variants. Several dynamic pricing experiments and are reported in that mainly the interest one of the important type are time of use pricing and critical peak pricing. So time of use or TOU pricing and real-time pricing (RTP) programs are designed to lower system costs for utilities and bring down the customer's bill by raising prices during the expensive hours and lowering them during the inexpensive hours. Actually, the former fixes the price and time periods in advance, while the latter fixes neither the price nor the time period in advance. Real-time pricing, there will not be any prior information regarding the price and time, but in time of use pricing, they will definitely inform for this particular period this will be the price of the energy. So a customer can manage their energy usage by shifting the high price period to low price period. So time of use rate can be considered as a static, while RTP, real time price rate, can be considered as dynamic. So there are various kinds of tariffs available. So as you all know that a flat tariff, the price in case of a flat tariff, the price remains static even though the power demand changes. So customers under such a scheme do not face the changing cost of power supply with a change in the aggregate demand. So that the consumers have no financial incentives or benefit in case of a flat type tariff. But in a block rate tariff, the scheme is differentiate between the customers based on the quantity of electricity consumption. So there will be a different level. The scheme consists of multiple tiers characterized by the amount of consumption. That is what actually happening in our system. There are different blocks, and each blocks are priced by different energy price. Then seasonal tariff is there. That type of seasonal tariff means that the energy prices will be different for different season. But the actual dynamic pricing consists of the main one of the important variant is time of use pricing or time of use tariff. So these are the pre-declared tariff varying during the different times of the day, that is high during the peak hours and low during the off-peak hours. So such a schemes can stay effective for short or long terms. So this is sometimes known as time of TOD tariff. Hope you have the idea about the TOD meter also available nowadays. That is the meter measures the energy consumption, but for a particular time of day. So the time of use pricing, this right design features prices that vary by time period and are higher in peak period and lower in the off-peak period. A time of rate is slightly more complex and involves two pricing period within a day, a peak period and a off-peak period. So peak period they will have a minimum, there will be a two period, that is peak period and off-peak period. Peak period there will be a one type of tariff, electricity price, and off-peak period there will be a lower price. So time of use pricing is a common in developed economies at all stages of market restructuring. And a residential time of use rating are offered on a voluntary opt-in basis by utilities in all type of climates within the US. They are still offering an optional basis. The customers can opt whether a flat rate tariff or a time of use tariff. They can opt the particular tariff for their electricity usage. Then critical peak pricing. So critical peak, this is a dynamic pricing scheme in which prices are high during a few peak hours of the day and discounted during the rest of the day. So the peak price remain same for all days. So it gives a very strong price signal and enhance the reduction of excessive peak load. That is a rate design offers a very high price during the few critical hours of the year or hours of the day. It can also be combined with a TOU rate. Uh, Sometimes typically a CPP, critical peak period, that is a high price period, is only for 12 to 15 days in a year. So under this rate particular tariff, customers are on TOU prices for most hours of the year. That is the remaining time period. Or if the critical peak period is mostly critical peak pricing and TOU are combinedly using, and for a few days in a year, that means few hours in a particular day, typically 12 to 15 days in a year, they will charge very high price for electricity. Or other days they will follow the time of use pricing. So customers are on time of use price for most hours of the year, but additionally face a much higher price during a small number of critical hours when system reliability is threatened or very high prices are encountered in a wholesale market because of the extreme weather conditions and similar factors. That is, whenever there is a shortage in the energy, such a situation will come. Whenever such a situation comes, the electricity price will be very high. Otherwise, the price will be as per the TOU price, time of use prices. Then real-time pricing. So this is the purest form of dynamic pricing. That is and the scheme with the maximum uncertainty and risk for the consumers also. Here the prices change at regular intervals. The prices will be changes at regular interval of sometimes for a 1 hour or a few minutes. Even within a few minutes the price of the energy will be changes. So the change in the price in such a small interval increases the efficiency of the pricing scheme in reflecting the actual cost of the supply. But this kind of a system is actually demanding advanced technology to communicate and manage the frequent changes of the prices, because in order to measure continuously the energy, and we should inform the consumers within a short period what is the electricity price for a particular time. So for that it is required an advanced technology to communicate. Advanced metering infrastructure is important in order to implement a real-time pricing. And so actually the retail electricity market may find it difficult to practice this type of pricing because of the high rate of data collection and transfer is required. So here you can see one of the figure which explains the impact of real-time pricing on Chicago residences, and you can see the uh, uh, price whenever the price alert send what is the peak value of there are two graphs you can shown. First one for with control with the price alert, and with second one for the without price alert. So whenever we are monitoring the energy and informing the electricity price real time manner, definitely consumers will encouraged to reduce their low demand. So if here you can see that this one graph is the peak demand is lower than that of without information. The high peak graph is the which corresponds to the price whenever they are not informed the electricity price. So whenever we inform the electricity price, the peak demand can be reduced. So this shows the advantages of a real time price. So the customers are notified the rate on a day or ahead or hours ahead basis. Sometimes in a realistic manner, here the price changes at a regular intervals of even within the 1 hour, or even within a 30 minutes or 50 minutes, etc. So this is the purest form of dynamic pricing.